What are we looking at here? Pluto orbits the Sun at an average distance of 5.91 times 10 to the 12 meters. Pluto's diameter is 2.3 times 10 to the 6 meters, and its mass is 1.31 times 10 to the 22nd kilograms. Charon orbits Pluto with their center separated by a distance of 1.96 times 10 to the 7th meters. Charon has a diameter of 1.21 times 10 to the 6 meters and a mass of 1.55 times 10 to the 21st kilograms. We're looking to calculate the magnitude of the gravitational force of attraction that Pluto exerts on Charon. The force of gravity between two separate objects, well, we know an equation for that. That's the G m1 m2 over r squared equation. So if we know G, m1, m2, and r, we're all set here. Remember, capital G is that universal gravitational constant. It's always the same, and it has a value that you can look up in your reference tables. 6.67 times 10 to the negative 1 Newton meter squared per kilogram squared. Next, M1 and M2. Well, M stands for the mass of the object. Let's see if we can find those in here. Looks like we have the mass of Pluto, 1.31 times 10 to the 22nd kilograms. The mass of Charon, 1.55 times 10 to the 21st kilograms. And so we can just plug those right in to our equation. Divide all that by r squared. Now, what does r represent in this equation? R represents the distance between the objects. And out of all of the information they gave us, the distance separating the two objects is 1.96 times 10 to the 7 meters. And so that is the value that we're looking for when we plug in for r. And don't forget to square it. Throw all of this into your calculator very carefully, and the value you should wind up with is 3.58 times 10 to the 18 newtons. Now, as always, you should be thinking about your answer. That's a large force of gravity, but we're keeping a moon in orbit around its planet. So we would expect that we would have to pull very hard in order to keep an entire moon in orbit. So this seems like a reasonable answer for that. 73, 74. Calculate the magnitude of the acceleration of Charon towards Pluto. So we want the acceleration due to a force. So we have an equation for that. A equals F net over m in your reference tables. For the force these objects out in space, the only force we need to consider here is gravity. So we can take that force of gravity that we just calculated and plug it in as the force. Now what about the mass? Well, which object are we talking about here? We want the acceleration of Charon. And so for the mass, we should use the mass of Charon, which you could find right here. 1.55 times 10 to the 21st kilograms. Put this into your calculator and you get an answer of 2.28 times 10 to the negative 3 meters per second squared for our acceleration. 75. State the reason why the magnitude of the Sun's gravitational force on Pluto is greater than the magnitude of the Sun's gravitational force on Charon. So let's look at our equation and see if we can figure this one out. What are the values or that would affect the force of gravity between these two objects? Well, we've got the gravitational constant, which is always the same, the masses of the two objects, and the distance between them. Well, looking at this, what's really the difference between Pluto and Charon? And looking at this, why would the Sun pull harder on Pluto than it would pull on Charon? Well, the mass is part of this equation. So let's compare the mass of each of these two objects. Pluto has a mass of 1.3 times 10 to the 22nd kilograms. Charon has a mass of 1.55 times 10 to the 21st kilograms. Notice, Pluto has more mass. And so the force of gravity between Pluto and the Sun should be larger than the force between the Sun and Charon. So the answer we're looking for here is because Pluto has more mass.